In this video, I'm going to show you my process for shielding a guitar. Before I start narrating what I'm doing with the actual technique of shielding, let's talk about what shielding is for, what it can do to help, and things that it can't help with. So, shielding helps prevent some of this radio frequency interference, this electromagnetic interference that's always bouncing around your room, from invading your guitar's tone and ending up coming out of your amplifier. To do this, shielding is an attempt to capture that rogue interference and send it somewhere else that isn't your main signal path. To do this, we have to surround the electronics with a bunch of conductive material. You can see here that the conductive material that I'm using is copper tape. I'm going to cover the entire cavity of this guitar body, the cavity that has all the electronics in it. I'm going to cover it all with conductive copper tape. Doing so will help intercept the incoming radio frequency interference, the RFI, and capture it within the copper tape. Then we need to send that interference somewhere. If we don't send it anywhere, it's just going to be collecting on this copper tape, building up, and it will end up in our audio path. So we have to send it somewhere else. And where we send it is to ground. Now I'm going to use a metaphor to kind of help illustrate what shielding does and how it behaves. Think of radio frequency interference as rain. Okay. When it rains outside, you would like some kind of barrier, some kind of shelter from the rain. And that's why we have roofs on our houses. So the roof, captures that rain. The rain hits it so it doesn't hit us. But if we didn't send that rain somewhere, that rain would collect on our roof, and maybe it would run off the sides in a sloppy way, but either way it'd be a nuisance if we didn't collect that rain somewhere and send it where we want to send it, where it's useful for us for that rain to go. So we have gutters. We have gutters on the perimeter of our roof so that when the rain hits the roof and shelters us from it, that rain runs off the roof into the gutter. That gutter collects the rain, sends it to a downspout. The downspout then sends the rain out into the yard where it's not going to be a bother to us. So what shielding is, it's like a roof. It collects the radio frequency interference, but that's not enough. We need a downspout. We need some place to put it, and that is the connection to ground. Now, electrical ground is a complicated subject. I'm not an electrical engineer, so I don't want to get into the weeds here, but basically what a ground is it's actually a connection in your home to the earth. That's why it's called ground. And the earth has a slight charge to it, so there's a potential to ground, meaning that electrons kind of want to flow there. So if we take this interference, which is basically electrons, and we collect them on this copper foil, and we give it a path to ground, it'll take it. And that's great news for us, because if it's going to ground, that means it's not going to our amplifier and creating a buzz, a hiss, a hum in our tone. Shielding will help with hisses and buzzes, higher frequency radio interference, but it won't help you with 60 hertz hum, which is a big problem for musicians. That wavelength is just too long to be captured by this thin copper foil, or if you use shielding paint, it's just not enough material to capture those waveforms. Just won't work. But if you can keep your expectations low, you will find that shielding does minimize unwanted hisses and buzzes. Now, this whole procedure of shielding took me a little over 2 hours. Now let's talk about the nitty-gritty here. So what this is shielding tape with conductive adhesive on the back, which is important. Every time I put down a piece of tape, I'm making it touch another piece of tape that I previously put down. What that's doing is it's creating an electrical continuity between those two pieces of tape. I want every piece of tape to be electrically conductive with every other piece of tape that I put down. So you have to make sure that you buy tape that says that the adhesive is conductive. The adhesive, of course, is the sticky stuff on the back, and that adhesive is going to be touching the copper on the front from the previous piece. So you want the electricity to be able to flow from one piece to the next. So you need that adhesive conductivity. So what I'm doing now is I'm using my multimeter on its continuity setting so that I can tell if the distant portions of the shielding are in fact electrically conductive with one another. You can see how I'm touching the two probes and they have a value, 0, 0, 0. But when I release it, it says OL, which means open line, which means that there's no continuity between the two probes. So the hope is when I touch one piece of the conductive tape and another piece, I should get continuity. I should see a number, which I do. If I see OL, that means there's no continuity between my two probes. There's no continuity between those two sections of the shielding that I put down. And it looks like we're all good. So this bit, it was a bit tricky, so I wanted to show you all this. I have to line this very tiny area where the output jack goes. So what I do first is I line the walls with this tape, and this is very thin material. You can think of this material as the wrapper on a Hershey Kiss. That's how thin this material is. Very easy to rip, very easy to fold. That's why this process takes a while, because this copper tape is not easy to work with. I'm using this little dowel as a way to manipulate the tape once it's attached to the surface of the guitar. It's just like an extra skinny finger that I can use. Now another option would be to use shielding paint, which is basically paint that has conductive material in it. And you could paint the inside cavity of the guitar and get a similar result. The downside is it's a bit messier. You have to paint. The upside is it's a little bit easier to get into the nooks and crannies. So it's You know, it's a judgment call you have to make. I prefer the tape. I'm trying to open the hole back up that connects the main cavity with this smaller output jack cavity. I'm going to need to fish wire through there. So what I did there is I used a old guitar string to poke a hole through that tunnel so that I can see where it comes out the other side and clear it all out. Now, if this looks tedious, it 100% is tedious. This is not a job for someone who gets bored or impatient. You can see that I folded a little bit of extra shielding tape over one of the output jack plate screws. This way, the output jack plate will be electrically connected to the shield, and you get a little bit of extra shielding from the output jack plate. You're basically making it part of the whole shielding system. Here I'm test fitting the pickguard to see if there's any exposed shielding tape from beneath the pickguard. So the last little bit of shielding tape needs to go down into the output jack cavity. And I wanted to give you a good look at how to make a pretty good estimation of this odd kind of egg shape that is the output jack cavity. You take the shielding tape and lay it over the hole, and then you use your fingers to kind of make a dented outline of the hole while the backer is still on the tape. What this does is it gives you a perfect representation of what the shape of the hole is, and then you cut a little bit inside of that shape. Now that was the easy part. Now we have to get that shape all the way down in that hole somehow without any of the adhesive on the back of this tape grabbing onto the sidewalls on its way down. So here's a little trick. You take some Scotch tape, fold it over, and then you press it against your jeans, press it against something, some piece of cloth, and it'll pick up some lint, making it a little bit less sticky. Now you'll see why in a moment, exactly why you need it to be less sticky. We just need to be sticky enough to hold that foil, and since the foil is featherweight, I mean it weighs almost nothing, we don't need it to be super sticky. So you see I'm picking up some lint there off of this little blanket I have, right? And I'm then sticking the lint side against the foil tape. I'm hoping that because of the lint on the adhesive of the tape that I will be able to lift the screwdriver up off of the tape pretty easily. It went well, but not perfectly to plan, you'll see. I use the screwdriver as a positioning implement. So it was a little fiddly, but not too bad. All right, now I have two cavities, the main cavity and the output jack cavity. But they are not electrically connected to one another. See the open line? We need these two cavities to be connected to ground. So I need one cavity to be connected to the other, and then I can connect those to ground. So I'm going to measure out a length of copper wire here. And I'm choosing black because black is accepted, at least in the guitar world, as being the ground wire color. I'm going to strip a length of insulation off of it. This tool is great, but sometimes thinner wire doesn't want to bite. There we go. So I'm removing the insulation off of these two lugs. I don't need that insulation. I just pull it right off. Now those lugs are designed to be crimped, but I'm going to solder them. So the tip of the soldering iron is roughly a cylinder. It's a conical cylinder, and the lug is a cylinder. So two cylinders touching each other does not transfer a lot of heat. So putting a little bit of solder on the tip of the soldering iron will allow the soldering iron to have more contact with the lug and transfer heat better. So what I did is I put some solder down inside of the barrel of that lug. And now I'm going to heat up the lug, melting that solder, creating a pool of solder inside of that barrel. And then I'll just dip the wire in there and remove the soldering iron, let the solder cool, and the connection is made. Now notice I had to apply more solder to the tip. It took me a while to heat up that solder inside of the lug, but as soon as I put solder on the tip of the soldering iron, that solder in the lug melted instantly, and I was able to make a quick connection. Now I have to fish the wire through that little channel before adding the second lug, because that hole, that channel, is not big enough to allow a lug to go through it. So I have to solder it in place. I'm applying more solder to the tip. Now I'm applying heat to the lug. Now I'm just filling that little hole in the lug with some solder. Remove the iron. The solder dries, it solidifies. Now I'm going to reheat that solder and then stick that wire inside of that hole. Remove the soldering iron so it dries, and the wire will be permanently attached to that hole. Super fast, no problem. Now I just have to screw it into the body. Now that lug screwed into the body in the main cavity and the output jack cavity, that lug is the connection to the cavity, to the shield. So now, after I do this, the two cavities will be connected to one another electrically. All right, once again, I'm going to check continuity with the multimeter. This time, I'm going to confirm that the cavity, the main cavity, and the output jack cavity are connected. And as you can see, they are. They're electrically connected now. So both cavities will be now part of the shielding circuit. All right, we have one more surface to shield, and that is the underside of the pickguard. Doing so will almost completely encapsulate the electronics within a shield. Now, you can already see that there was some shielding applied by the manufacturer around the tone knob, volume knob, and switch. And that probably is enough. By adding more shielding here, I may not be making a huge difference, but it can't hurt, so I might as well do it. My philosophy is the more shielding, the more chance of capturing this interference and sending it off to ground. Now, if you remember from the body, I had deliberately left shielding tape spill over to the flat surface of the top of the body. The reason why I did that is because that shielding tape that is spilled over will contact the shielding tape that is being applied right now to the underside of the pickguard, and it'll make an electrical contact. There will be continuity now between the pickguard and the electronics cavity on the body of the guitar. since the electronics are grounded and they are going to touch this pickguard and the shielding on the pickguard, that means that the shielding on the pickguard is going to go to ground, and the shielding in the cavity will go to ground because it's touching the pickguard once it's installed. An X-Acto blade is great for this type of thing. I'm just going to cut away all of the unnecessary shielding from all the holes using an X-Acto blade. As I finish this up, you can see that the part of the pickguard that will be directly over the electronics cavity of the body of the guitar, that part of the pickguard has now been covered in shielding tape. And as I said before, the shielding tape that's on the body will touch this shielding tape, creating a connection there. This shielding tape on the pickguard will touch the ground of the electronics that will be installed in the pickguard, and that ground will be connected to the ground of the house. And all of that is a nice, safe path for this radio frequency interference to take, and it will not interfere with the tone coming out of your amplifier.